Thank you very much, everybody, and glad to be here to speak again at Philly ETE. So my talk today, we're going to talk about GraphQL. So there's a little bit of a pun up here if anyone's done any GraphQL at all. They have a kind of silly syntax for certain things. So the smarter is a way of specifying required elements in an array and in an individual element of an array. So we'll look at that later. So that's what we're talking about today, GraphQL. What is GraphQL? How might you use it? So as you can imagine, GraphQL, QL stands for query language. It is basically going to fetch data and update data in a graph-like format. So it's a hierarchical set of data that you query by pulling out nodes that you're interested in by representing them in a query. And a graph, the actual graph schema that you create is defined by data types. And you'll see there's two basic types of data. There's input data types and there are general data types. So there are data types. You can imagine there's a named thing and it's got properties in it. And then you can build queries that accept types as input, return types as output. You can have mutations which modify things and then can also return data as output from the modification. And then you also have the ability now in more recent versions of GraphQL for subscriptions as well. So subscribe to a data source and just get updated automatically by the server as it feels it needs to update you, as long as you program it that way. There's no free lunch. So this is an alternative to using REST, right? I mean, most of you, I'm assuming here, are using REST in some way, shape, or form, almost guaranteed that if you're doing anything on the server side, you're probably feeding a REST response, sending posts in and sending back out payloads, things like that with JSON. So this is somewhat of an alternative to it. You can kind of use them alongside of each other. Certain things work really well with GraphQL, certain things don't need it. So it's just another thing to look at as a potential option for your platforms. So you're going to take your concept of the get, put, post, delete verbiage kind of thing, the RESTful nouns and verbs, and convert over to more of an RPC style. You're going to build method names. Method names are going to do things. And so you can actually write a little bit more of a closer to RPC style syntax with inputs and outputs. And so obviously your queries are going to read things, your mutations are going to modify things, and your subscriptions kind of get updated automatically. So the benefits we have from something like this is we have a well-defined schema, which means that we can look at that schema from tools and reason about the schema too. Now I know we have that in REST as well, but they kind of started GraphQL from that perspective of having the ability to hook different tools up to it directly and get information out of it. So those tools are actually pretty useful. You can actually get kind of a graph of the entire kind of topology of your endpoint. So if you hit, usually you hit a single endpoint like /GraphQL. You'll see that when you hit that endpoint, you can hit it with metadata queries. And all these tools use those metadata queries to ask about, okay, what's in this particular schema? Give me the schema syntax, give me all the methods that we have in that schema, what are my mutations, what are my queries, what are my input types, my regular types. And it can do things like give you automatic code fill-in features for your tools, or give you a graph of the data, for example, or show you documentation if the API provider has done that. The other thing is you really only need to query, and specifically around querying and mutating, really, these two things. Well, technically subscribing, actually, now that I think of it. You only subscribe to what you need. So you ask for the things you need out of the graph. Now, if you think of that, if you start thinking ahead, if you're a server programmer and think, well, what does that mean to me as a server programmer? Correct question, right? Because you might build an endpoint to get some list of customers. And this is not going to sound unfamiliar to you. Do I give them a deep list of everything, all the different subparts of that customer, their orders, their order details, and everything else? Do I build that query and bring all of that back and then let GraphQL only select a little bit of it? That doesn't sound right to me, because that means you're probably doing a lot of work on the server that might get thrown away sometimes. So it's not what this is doing is going to give you instant benefits performance-wise. You still have to reason about how you write the server. So it's not a panacea. It's not going to solve every problem. There are GraphQL servers out there. Prisma, for example, is one of them. that will hook into databases and do queries for you and look up things. I have not used them, mostly because of my deep pessimism and having things do that for me. I'd rather have control over them as a server developer. So instead, you may be writing things like a shallow versus a deep query call, right? So your GraphQL call might say, give me the shallow details for this thing. And if it really is a deep tree, you might then have another method, another query that goes deeper. So those are the kinds of things you may end up having to optimize ultimately. So it's just merely a protocol, and it gives the server the ability to select a subset of what you're looking for. It's up to you to figure out how you fetch that subset, whether you fetch it all and give them a little, or you only fetch a little. So that's on you. All right, I already talked to the Open Metadata Querying API. Another interesting thing, and you've probably seen this from things like Postman and other tools, you can usually get these querying tools to give you a curl URL, for example, so you can test it just from the browser. Because after all we're really doing here is we're doing a post to one endpoint. It's going to sound really familiar from the old days. We're doing a post to one endpoint, and we're passing in a query. And then it's going to send a response back in JSON format that we turn into a JavaScript object, or whatever the client API is. So that sounds probably pretty familiar. And that's kind of what we're doing here, is we're basically using a little tiny subset of REST, enough to get a query over, or a mutation over, or a subscription over, and then deliver the results back as they come in, or whatever you want, as a JSON document. And that's what happens with GraphQL. Here's a really simple beginning GraphQL schema. So we have, if you look at the bottom first, actually, we've got a type called quiz, and then we have a query that uses quiz. Let me put my little notes in here. So up top, you see that our query, we take our GraphQL types. We're saying if I call get quizzes, now that's a method. It's called a query method. You don't see parentheses there, and this is kind of an interesting thing about the syntax of GraphQL. If you don't have parameters, you don't use paren. It's actually syntactically incorrect. So it's a little bit of a goofy syntax. So if you have no parameters, you don't put parentheses around where the arguments would go. You just put a colon in instead to end that particular thing. So for get quizzes, we want the quizzes back as a list. We don't have any parameters in that example. So then you say colon and then the return type. We're going to bring back an array of quiz objects from the schema. And that array of quiz objects from the schema, each one is required to be a quiz. This is where we get to some goofiness with the syntax yet again. I can bring back an array. I might not bring back an array. But if I do, I better be giving you quiz objects in the array. That's how you read that statement. That may not be what you want. You may want to always bring back an array and make it empty, right? So if you make it empty, it would be another exclamation point at the end of the array. So bracket, quiz, exclamation point, bracket, exclamation point. So that's what the joke was in the beginning of the class. It's goofy. We'll blame Facebook, they wrote it. So then we have another one, get quiz, and this time we feed it a parameter. And I should mention another interesting thing about the API, about the definition. They do not really care about the bounding of the length of numbered variables. They're all just called int. So if you have a long being fed in or whatever, you have to unpack that properly on your client side. And in Java, that gets fun because IDs are longs and things like JPA and stuff. And so you're looking at it going, well, I can't fetch it because it's yelling that the wrong data type is being passed. So you have to do a little bit of finagling of the types. But they don't really have any bounds checking. They just have one number type, and it's called int for the integer numbers. And so that one is going to take and require an int of the quiz ID, and it will then have to return back a quiz. All right, so there's the example of that. And the types, there are some primitives. It's your typical string and Boolean and int, and I believe I forget if it's float, but there's a floating point number, or at least a numeric with decimal points. There's a couple of those, Boolean. And then you can build types from other types. So it's a pretty basic language. Now, what does this look like from the programming perspective? We've mounted our schema. I'm going to sidestep how that's done for the moment. We've set up GraphQL, And this example here, we're seeing an Apollo GraphQL client. So Apollo is an open source project team that has built an API called Apollo GraphQL. And Apollo GraphQL has a client and a number of different types of, actually a couple different clients and a couple different servers that they've been working on over the years. What we're looking at here is the regular old GraphQL Apollo client. And so imagine that first import there, I've already written the thing to set up the client, which there's a little bit of boilerplate. You have to tell it where it's going, what the URL is to point to for the GraphQL endpoint, what type of networking you're using, that kind of stuff. And so once you've established that, then you can make a query. You can say, give me the client from wherever you're storing it, and then you can call the client.query method. And the client.query method just takes an object with your parameters. And there are things like your fetching policy and other settings. But the most important one, obviously, is the query. Right? So if this is a query, when you're fetching things, read-only, then we're saying, go ahead and bring me back this query. And they have a little library called GQL, GraphQL Parsing Library. It just makes sure you're syntactically correct. So that is the JavaScript syntax to call the GQL library to wrap the syntax of your GraphQL statement to make sure that it's correct. And that's all they're doing there. So when you execute your query, it's going to do a post to the URL that represents your GraphQL endpoint. It's going to submit the query called getQuizzes. And then it's going to, since it didn't have any parameters, it's going to say, okay, I'm going to bring you back all the quizzes. And then you have to pick out what you want out of that collection. And in that collection, there we go. In that collection, we have a property called name and other properties as well, and things like the questions that they have. And then for the questions, we have the options and so on. So there's kind of this graph that can go depth first to wherever you need it to go. And you just keep adding braced object references to these different, sub things and referencing their fields. When you execute it, as long as you brought all those things back again, you'll get them back as JSON objects. Now we talk about mutations. So mutation does something, it manipulates something, and it might also return data. But let's take a look at some of these things. So we have a mutation, for example, vote on current question. Right, let's say we're playing a quiz game, and we brought back the quizzes, we picked a quiz, we started the game, and we were presented with a question somehow, and we want to vote on it. So in REST, you would do a post, right? Or maybe a put, depending if you're creating something versus updating it. But we don't have that distinction in GraphQL. We just have mutate, right? So you're creating mutation, and you're sending the data to the mutation. Basically, you're calling a function using GraphQL as a syntax. So we have this mutation type. It's vote on current question, and the answer coming back is, the answer being fed to it for the answer is a string. And then we should get some sort of score data back, which is another type in my schema. Right? So there's your payload. And you could define it as a type. So there's a type score data. It has a property called correct, which is a Boolean. And it has points, which if it's correct, will return. Hence, we don't have the exclamation point there. Right? So there's your optional versus required. And that's the payload coming back. So that's an example of something that changes the server, but then returns a payload back. And unlike REST, which is very formal in its, well, okay, if you're going to do a put, then you should probably bring the object back with its key, for example, right? Or at least put it in the location ID or something. If there's like a semi-formal way of doing it, it's up to you with GraphQL how you want to work with your calls. They don't really get in the middle of it and say, well, the style in GraphQL is X. It's just, are you making a change? Are you querying something? And that's the only thing you really care about from the protocol perspective. All right, so a mutation can be called and fed a parameter and then return some sort of result. You might also have more complex input. So for example, maybe you're signing in, and by the way, we'll talk about this in a little bit. Security is kind of interesting in GraphQL because you've got one endpoint. So you have to get a little fancy with the way you do your security. In this example, we're assuming that we have an open GraphQL endpoint, and the endpoint's going to let us log in. And then when we sign in, we're going to get some sort of token we can hold on to send back every time, so we're secure. So in that case, we feed in an object called credentials of the type sign-in credentials. Now, that type is an input type. Types that are fed in through parameters are called input types. So instead of saying type whatever, you say input whatever. And I don't know why they did this besides separation, but they've decided that input types are different than type types. I think they're both really types, but they don't call the other ones output types or read-write types, whatever you want to call them. So there's just input types and types. I didn't name them. So we've got our input type here called sign-in credentials, and we've got properties username and password. Excuse me. And again, they're just special input types, purely for input of data. Now to call this, I'm going to use the GraphQL Apollo client again. I'm using the JavaScript 20 whatever async await example. So I'm assuming my function was called with an async flag, and then I'm calling await to wait till it's done to move on. But that's trivial. It's just kind of grabbing it from some code I had. But the important thing here is it's going to be client.mutate and an object. And now instead of query, it's mutation. So that's all you really do. And now the syntax for that is a little bit novel. So we have over here, excuse me, we've got our mutation. And the interesting thing is when you name things and pass parameters in, you kind of have this formality of the query itself gets named. So you see we have mutation answer question. It's a named mutation query. Could be foo, it doesn't matter what it's called, but there's actually a property in the metadata it's sent up that says this is the name of my query. For whatever reason they use that, there's probably a reason for it. I haven't really dug into it yet to know. But it should come back with the answer too. So, in fact, the payload is named the name of that mutation, so that's probably what it is. But the point being, the first line, you then say, okay, I've got this particular variable that I'm going to substitute, and here's the type of it. That's an input type. So bottom line is I'm creating a query. I'm happy to call a mutation query called answer question. I'm feeding it a variable called answer, and it does have to start with a $sign. That's part of the syntax. And that is of type question, answer, input, and it's required in the schema. So that better be there for me to run this query or it's going to blow up. Then you'll notice the curly braces there on the right. So I open up the actual detail of it, and I've got the mutation name in there. That's the mutation name from the schema. So answer question. And then the name there, input, happens to need to match the name in the schema for that parameter. So at top, that's the variable name that we feed it when we actually do the call. So we're going to send in a variable with the name of answer. In the middle there, we say we're going to map answer to the field named input in the parameters of the call in the schema. So it's this mapping of outside to inside. Outside $answer, which is ultimately called, you'll notice answer in the variables. Answer is fed in as the variable called input as the argument to answer question. All right, so there's a query signature with a param name and type. There's the actual schema mutation parameter and the variable that gets it from the substitution that feeds it. Right, so the $answer feeds input in the actual call. Then, and this, by the way, I've done this both in Java and in a number of other APIs now as my, checking out the different APIs. Java has the same deal with this. You'll still do exactly what we're seeing here. You will then tell it that the mutation has a variables set, and that variable set is just a little object that has the keys and values of each of the things you want. And because answer is an object type, right? Answer maps to input, and input is the question answer input type. So that's a type that has, I don't think I have the schema here, it's in the other one, but that's a type that has the key and the quiz. Those are the two properties that it's fed. In that case, I'm feeding those, going to fall right off the side there, feeding those from the outside world incoming. So those are coming into the function in JavaScript. So it's a little bit of a goofy syntax. I figured I would give you an example of one. So if you're experimenting with GraphQL, you could throw this thing open and say, all right, that's the right syntax for that thing. Now that is a formal named query. You could skip that if you're just playing around with the query tools, and you could say mutation, answer question, input colon, and a JavaScript object in there, like the same shape as the variables. You could just slap the variables in there, but then you would, if you were going to do that in your code in a regular front end, you'd have to do the string processing yourself to fit that stuff in. Right? You'd have to concatenate all the strings together to make it work right. This is doing the string concatenation for you and taking care of all the escaping and all that kind of stuff. So that's why you'd want to use the variables property. Okay. Are we okay with queries and mutations so far? I mean, obviously it's not every example, but that gives you an example of some of the things you can get away with and do. And we'll do some querying in the tools. I'll show you how this works. Let's talk about subscriptions now. So a subscription acts as a server-side push for message delivery. Typically, you do it through WebSockets, although there are other options. For example, you could consider doing polling instead. I have not set that up, but I did set up standard queries with polling, and I'll talk about that at the end. It's just a regular query, and I'm just refreshing it over and over again as an alternative to the WebSocket configuration. So WebSockets, the idea is the client connects up the channel with the server, and now the server can communicate back with the client whenever it needs to. All right, so these GraphQL server APIs generally have support now, Apollo, and also Java GraphQL allegedly, side note, because I had a hard time trying to get that to work with subscriptions. But a number of these should have subscription support. It's a relatively new feature. So all the APIs are getting up to speed with it now. So obviously they auto-refresh themselves and they notify the client by sending the message down the channel to the WebSocket. And that means also you have all the WebSocket management issues you would typically have, like what if it hangs up on you? You know, how long do you keep the channel open and things like that you would have to configure in a production application. So this isn't a trivial thing to set up. And in fact, you have a separate endpoint for subscriptions when you set up your clients because they're a WebSocket. Right? So generally they would be different URLs, one for your regular GraphQL, and then one for your subscription endpoint. So generally you have two. And the clients are set up that way where they expect a subscription endpoint to be different than a regular GraphQL endpoint. All right. And again, their support's kind of all over the map. Come back in a year, it'll probably be really solid. And also some of that could be me wrestling with it because that stuff can be complex. So I did have this working in GraphQL Apollo. Where I had trouble was in managing the connection and make sure I know who you were coming back again. And I did get that licked, but there was a lot of like Stack Overflowing to get it to work. So that was with the Node.js side. On the Java side, there were very few examples and none of them worked to the point where I could trust it. It would keep hanging up the socket. So I'm like, forget it. I'll check back with them later. All right, let's look at subscriptions. So subscription is another type, just like query mutation. We've got subscription, and it's, you give it the name of the procedure and function, whatever it is, and you give it the return type. It can also take input parameters, just like a query or a mutation. And its job is to return data back. So I'm assuming here a somewhat complex type. I've got a gameplay message, and when the game is over, it flips the game over to true. And I've got a leaderboard that comes back, and the leaderboard better be full of leaderboard entries. So if there's an array, every element of the array has to be that type. And there better be an array because I said, give me one. So it can be an empty array. It's just when you start filling it, it better be that type. All right, so there's our, looks kind of like a query, but refreshed by the server. And again, this would connect up with a WebSocket and start delivering data to you. Now, just one quick note, we were looking at those little optionals and exclamation points. So I figured this would be, a little goofy thing to make us laugh at a little bit. So a thing is a thing, right? If I just say thing, it's an unrequired thing, right? Any variable that is a particular name in a position without an exclamation point, it's optional. So it might be there, it might not. If it's a thing and it shouts at you thing, then it's required, whether it's an input or it's a response. If it's a thing in brackets, it's an array of maybe things, maybe nulls, right? You might have an array of nulls, which is weird. So I don't know if you really ever want to use that. You just might have it that you have an exclamation point in the middle to make sure that the things you bring back are things. All right, so there's that. Give me things back. If you're going to give me anything, give me a thing. It's got to be there. Don't give me an empty array element. And then, no, I really want an array, even if it's empty. And if it has values, it has things. So that's just a little bit of a goofy thing. So, all right, let's talk about tools. All right, so there's a lot of tools out there for GraphQL, and they're varying quality based on who worked on them and how long they've been around. There's some pretty good ones out there, though. So, for example, schema mapping tools, right? One of the things you're going to do is build a GraphQL schema, and they're going to use that schema, hopefully, to write code, right? That's the whole point of this thing. I got to write a bunch of code. So if I'm going to query against this thing, wouldn't it be nice if I had types, right? Actual types in TypeScript or actual types in Java. So they do have a code generation feature, and the idea is you'll have your schema file out there, and as a developer, one of the things you can start up is a tool that watches that schema file, and when it sees that it's changed, regenerates the types in your native language that you're working with. TypeScript, Java, Scala, I believe, a couple others. It's not a comprehensive list, but there are some out there. Mostly JavaScript, TypeScript, and Java, the ones that I experimented with. All right, so there's a project out there called GQL Gen, and GQL Gen looked like the most rigorous and useful of these tools that I've found so far. So some of the tools give you this very enterprisey, very, in all the wrong ways, very big, long, crazy names for things, like a SOAP client generator would. Anyone remember those? The thing with this thing because it's a thing with stuff on it. I don't need that. Give me the actual type in the schema, I'll be happy. So GQL Gen gave me as much of a native type for everything that I had in schemas as would make sense to a rational human being. So it did a pretty good job. And it will generate, again, TypeScript and Java, and there were a couple other languages out there. Flow types if you're a Facebook Flow developer. And it can even do, though I haven't played with these, it can even write the clients for you. So it can write, basically like code that will interface with the server. Your mileage may vary there. I'm not sure how robust those clients are that get generated. But you usually don't really need them that much once you learn the syntax anyway. It's not that complicated of a tool. In terms of distributions, there is official, just kind of setting up for the next set of tools, there's been this Apollo project from Prisma, and that kind of helped us feed the reference implementation, if I remember correctly. And so Apollo GraphQL is out there, and it's a big honking set of things, right? There's a server, there's different server bindings for Happy and Express, and all sorts of JavaScript servers you might run into. And so Apollo has a lot of versions of APIs that hooks into different types of servers. And then it has clients for JavaScript. There's two of them. There's the regular Apollo client, and then there's the Apollo React client, which is kind of giving you a higher order component in React to inject the stuff that you need. So it's giving you some native React stuff to get your queries done. Then I got really excited for a while that there was this great API that just worked. GraphQL has a project out there, or I should say Apollo has a project out there called Yoga. And Yoga is a really nice convention over configuration, get started in 5 lines of code thing. So it was alluring. It seemed to work to a point. And then what happened was, as I did the research, they stopped working on it. So in the middle of all the research I was doing, when Apollo 2.0 came out, which was kind of an inflection point in the API where they broke some things and changed some things, they said, we're not going to do yoga anymore. I'm like, but that's what I was using, and it worked great. So they take away the things we enjoy, right? Otherwise, we wouldn't be developers, right? So, and then in the middle of working on other stuff, I just went to plain old, Apollo GraphQL, Apollo server. And I was getting somewhere with it, and I went back and checked. Like, we're thinking of restarting the project. So who knows, in a year, yoga might come back up again. They do have it in active development. They call themselves a Rails-like server for GraphQL, and I'm thinking to myself, oh boy. So it could be great. It could be, stuff that never comes to market, but you should pay attention to it because if it makes it easier to configure and it's robust, it may be a good thing in the future to look at. Because there's a fair amount of plumbing you have to do to set up this GraphQL stuff. And so if you could eliminate 60% of that, your life is so much better, right? And that's what they were trying to do with yoga. So we'll see where that goes. So again, those are JavaScript servers. Also, Facebook has their own React-based stuff, and they have Relay. Relay, I believe, is the client, if I remember correctly, but Facebook has some original APIs that they use. For example, Facebook doesn't expose their actual Facebook API directly to you. You have to pay money for that. Pretty sure that's still the case. Bottom line is they're not going to expose all their tools to you, but what they did was they open sourced GraphQL and they created a foundation under the Linux, I think it's the Linux Open Source Foundation, one of those. And they actually now have a foundation that's backed by all the major GraphQL vendors. So they've moved it out into its own thing that is now owned by a community as opposed to being owned directly by Facebook anymore, which is a good move. And so the official GraphQL reference implementation is implemented and it's basically owned by the standards body. And then Apollo and all these other groups, Java GraphQL, the Python one, the ones for Elixir and all these other languages, they all basically implement the standard as best they can. We'll see how that goes. But for the basic things, it should be pretty straightforward. There's a lot of other GraphQL APIs out there. And so all of these things together use a standard set of query tools and a standard set of query APIs. So we have tools like the GraphQL Playground. Now you can mount this thing in your web app itself. You can just basically set up an endpoint. So for example, on the JavaScript side, there are ways, if you're using Apollo server, there are ways to set it up and install the GraphQL Playground. Same thing on the Java side, there's GraphQL for Java, and there are some libraries to kick this thing off there as well. What it ends up being is just a client tool that gets downloaded to your browser that communicates with the standard querying APIs. So it's an interesting little tool. See if I can mirror here. So here's GraphQL, and I have it connected up to Yelp. All I had to do that was sign into Yelp and create an API key. And so when I set up that API key, it threw it on my computer as a cookie on the browser. And then when I hit the site again, and you have to turn on this experimental beta which says, give me GraphQL. When you hit that, you can then start querying. And what I like about theirs is the documentation is relatively decent. So the way it works in the schema is you can comment every field. That's kind of like Java doc or JS doc. If you include the right comments in the right places, the introspection tools, when it generates all the stuff it needs to and starts up the server, it holds on all that metadata as comment metadata. So then when you use a query tool to take a look at it, all that information is there. This is coming from the schema. Right, so usually these schema tools like GraphQL and some other ones that I use like Altair, they have a way of just getting to the schema and taking a look at what's in there. So what I have is a query that will search, it's a little too big, This thing here, this search call, is the built-in search call that they have in the schema for Yelp to query Yelp reviews. So I'm using exactly what we learned in the last couple slides. I'm hooking up and saying I'm going to pass in a search term. That's called term in the API, and I want a search location, and that's just a search location that I type in as if I was in the browser. You notice there the query variables at the bottom. Remember we saw the query variables in the API? This is just calling it just like the API would. When the API sends variables up to the server, it sends a JSON object with the variables. So you can do it here too. In fact, let me hit the query tool here. First, I'm going to go to, yeah, I'm not doing that. Thank you, goodbye. Okay. What I'm going to do, have my network open here. Hit play. Now when I hit play, the data on the right refreshed. Let's see if this is going to give us enough information. Yes. Down at the bottom of our GraphQL proxy, you'll notice it's a post. Right, there's the post there. That is their endpoint. Yelp.com/developers/GraphQL_proxy. That's the URL endpoint for GraphQL there. The HTTPS, it's secured. And there's my request payload at the bottom. It feeds it. There's the operation name. So that's that first part when we did the query with the variables to substitute. That name is called the operation name. Then it has the query in there as a string encoded. Then it has a property called variables. So just what we saw in our object payloads in GraphQL query, that's what it's sending up as a JSON payload in order to make the query call. And the response comes back as JSON. And that's it. Notice, so I was kind of thinking on my feet there, I was like, that's right, the name is the same when you come back. It's going to use a property called data, that's the standard. So whenever it hits it, the response comes back as a data payload. And the data payload then has the name of the query, the name of the operation, I should say, and then all the payload data beneath it, so business. So that's why they can make it easy for you to use tools like this. The really interesting thing is because they've standardized all of the metadata queries, they can do things like this. So I'm looking currently at the business name, phone, location. What other things can I query? Control space. Hey, that's nice. In a browser? I'll take it. What's the URL? And now I've got the URL with me. And there's more than one thing in here. Of course, now my demo fails because I can't scroll. Oh, demos. They're so much fun. Okay, so here we go. So ratings. Let's look at the ratings for our restaurant that we're looking at here. That's a real restaurant near me in Newtown Square, outside of Philly. So if I open up rating, I say I want to see the things in rating and hit control space, nothing happens because it's a demo. Oh, rating might not be one of the things with objects in it. Hold on. Yeah, that's it. Never mind. Hold on. Reviews. That's what I was thinking of. Reviews. There's the review data. All right, what's the rating that the user gave me? And let's get the text of the review for good measure. Now, has anyone here ever heard of Gatsby? So Gatsby is a server content tool. Like it basically lets you write what looks like React code for static websites. They have GraphQL integration with Gatsby. Think about that for a minute. So for querying dynamic data in your content management database, you could hook in GraphQL as a query language for it and get data out of your content database that way. Interesting thought. All right, so that's an example of using GraphQL. Voyager is another interesting one. That one sips all the data, gets an abstract syntax tree, and turns it into a picture, a live, movable document of the entire schema. So for that one, I loaded one already from, there's like a demo version of it out there. And if you do any kind of reading of GraphQL documentation, one of the most common demos they have out there is the Star Wars demo, where they've got all the Star Wars characters and creatures in the films and everything. And so this actually came from a live endpoint that they have for the demos. You can click on things and you can take a look at their metadata, click on another thing. It's a neat tool, and it's good for as you're learning a schema to get a feel for what it is. Okay, so and that's another thing you can install on your servers. There's a NPM module to install it. You just set up the right things in your Express server or whatever you're using. Happy if you're using that one. And there's also versions of this that install on your GraphQL Java servers as well, and other platforms. So that's called GraphQL Voyager. Even has the documentation, because they're all querying the standard documentation metadata from the specification, which is now live, and I think it's version 1.x now. But the spec is available, and everyone's going off the same spec, kind of like Java E or any other thing that's out there. All right, we looked at that already. You can also do plain old posts and such. Now, there's a tool I use that I like a lot called Altair. This is an Electron client, so it runs in your desktop. And all of these have settings, so you can change things like the font size. So if I want a really big font size, 30, 40, I don't think so. Or if you want to crash your whole system. I won't do that anymore because it didn't work. Oh, that's because I'm pointing at my own server. Please stand by. I'm in the middle of developing something, but I figured I would point you to the server real quick and show you what it looks like. I agree. This is a Spring Boot application, Java guy from way back. Applets, am I right? No, just kidding. Thank you. I got you to laugh. All right. So, because that is hilarious. Yeah, it's called Flex or whatever, or now this. It's called Angular. So this is just a Spring Boot application. And I wanted to show you, as long as it pays, yeah, there we go. As long as it does good by me here. I have an endpoint. And I think for the last thing I'll do, I'll talk about security briefly, then we'll take questions. But yeah, I have just enough time to do this. So with the security in GraphQL, you have a couple of options. You could secure the entire site like you normally do and do, cookie-based authentication or token-based authentication for the whole site, and GraphQL just happens to be there. But then that's very coarse-grained in like what option do I have to secure endpoints lower in? Or you could choose to have a deeper integration. And that means keeping your login in the clear, and when you trigger your login call, have GraphQL delegate to a security tool to sign you in. I'm going to put this stuff online in a couple days when I'm actually finally enough done with it. I'm not crying in a pool of my own tears. But I'm at the point where I'm just about ready to show this. And it's got a full Spring Boot system with Spring Security securing the client when it connects up. So I'm calling an open URL. The open URL goes through with a mutation in GraphQL and logs you in. Once that's done, now my entire backend can check to see what role I have and say I'm allowed to call this method only if I'm in these particular roles and if I'm signed in. And I actually have what you would normally do in an enterprise Java security model. All right, so that's what's working on that one. So to get that to work, I have to use some sort of mechanism to do it. So I'm using something called JWT, or JSON Web Tokens, which is a pretty common thing now for signing into a single page application. So the clients I have for this are doing that. They're signing in through this mutation on GraphQL. If they put the right username and password in the credentials object on the way in, they get a JOT token. JWT is actually pronounced JOT, apparently, or was when I learned about it. That thing there is my JOT token. Normally, the client would take that, store it in local storage, session storage, maybe put in a cookie, something. And that represents my realistic credential that I'm allowed to access the server. So it was signed by the server, sent back to me. When I call it back again, it says, okay, is this still the signed official credential for this person? And has it expired yet, yes or no? Oh, it's expired, then I'll say you're not allowed. And then you're supposed to rip the token out of your system. Otherwise, you're just hurting yourself by sending the same bad token back and forth over and over again. So I have this token, and now I can make a call. So my call would be get the information from the system. And they have a little thing in these query tools called set headers. And there's a header in JSON Web Tokens called the authentication header, authorization header, and it has a property called bearer token. Right? So authorization is the key, the word bearer, capital B, space, and then the token. And that's the syntax that JOT tokens use. So I'm pasting that in because we have the set headers option. And now I want to execute this thing. It doesn't work. Yes! Welcome to demos, right? Interesting. So it says access is denied. Fine, let me go back and log in again. See what's going on here. I might have pasted it wrong too. And if it doesn't work again, we're done and we'll take questions. Not the worst thing that's ever happened to me. All right, go back to headers again, bearer. And I don't have a space. Save. Yeah, something's borked, which is okay because I was writing code and I busted it, which is fine. There's my exception. That's my dinner. All right, but that gives you a little bit of an idea of some of the tools that are available to you. So if you're going to get involved in GraphQL, you're going to get involved in working with some sort of code generation for your model objects that are your inputs and outputs. You're going to have some server that you're going to pick, which there's a whole bunch of them to pick from. And there are ones on Java, and there are ones on Scala, and some others as well. So take a look at the GraphQL I think it's .org site, and you can take a look and pick one and experiment and take a look at the reviews. And these tools like Voyager and GraphQL, and the one I'm using is Altair, the desktop, which is a pretty good one, are all pretty useful. So with that, let me go over and see if anyone has any questions. Okay. So how does GraphQL relate to microservices frameworks? Can they be used together or do they compete with each other? You could run GraphQL on anything. The question is, do you need that level of complexity? So if you've got, and this is kind of one of the things that I had in the end slides, but I ran out of time here, so I want to just get to the questions. If you have 3 queries to do for a microservice, and they're really simple queries, please don't set up GraphQL. You don't need it necessarily. I think where GraphQL is a really good potential fit is, let's say you're building a product and you want to expose a querying API to your customer. Let them pick their tool. It's a decent alternative to REST because it lets them kind of query things ad hoc and learn about what they want. If you write code that's performant that way, because there's a lot of ifs here. But there's a lot of open tools out there that they can use to generate their calls. And so if they have kind of a graphical set of data that they need to communicate with some sort of hierarchy, and they want to be in charge of what they want to see, it's potentially something useful. That's where I think it would be a better fit than something like a microservice. But there's nothing wrong. You don't have to, you could do it with a microservice, just not sure what the benefit would really be since they're supposed to be small and targeted. There's a leading question. Can fragments be defined within a schema? So yes. So you can build a schema out of multiple fragments and have different pieces in different areas of your application. In fact, whenever you use your tools to load up your schemas, you can give it a path or multiple paths to find all of them, and it folds them all together, kind of like Spring does with its configurations. Can you do things like contains, et cetera? Oh, and so this is interesting too. You didn't see a where clause, did you? No. Because the where clause are the variables, if you think of it that way, right? So think of your GraphQL API is a nice way of picking what you want out of the results that are given to you potentially, but not to limit how many of them you get. Right? That's something you have to program, and to program that, you're going to need to pass it some sort of parameters to the method, and those parameters somehow need to be applied. And I mentioned this thing called Prisma. You can look into Prisma. If you've got a data set you want to experiment with Prisma on, you should be able to map it for things like database queries. I have not done so. I don't have enough time to really review something like that at my current stuff. And I figure, okay, it's out there, and there are a lot of tools like that are really heavyweight. So I tend to avoid those kinds of things. Paging-wise, I have seen some data sets where they give you current row, page number and next and previous page, and you pass the page numbering into the call, just like you would if you're doing paging on a client from a server in any other way. So there's nothing new there. It's not like they have some sort of cursoring, if that makes any sense. They don't have a cursor tool. You'd be doing something in software to do the equivalent. Give me the 15th set of results, 10 rows per set of results. That's like page 15, that kind of thing. Let's see. How do I implement a GraphQL API backend where the client can literally request anything? We had it. There it is, right? Anyone can do that. You can, in fact, all these GraphQL clients are open source. You can fork them, do your own client based on them. In fact, I believe that GraphQL has a programmatic API, if I remember correctly, where you can install their tool and then let people do queries. So you could do that, technically speaking. You're just basically opening up an editor, and you would then have to call the GraphQL parsing APIs to make sure it's a valid parsed graph. So you can build kind of open query tools in that language, and then anything else is up to you to build the right DSL for them to understand, to then generate the GraphQL in the right format. Why the need to explicitly specify mutation versus query? Good question. I think it's more declarative from our perspective. Technically there's nothing stopping me from making changes to code in a query, but that's a bad idea, So I think they just want to separate the two operations more than anything else. But technically they both have the same semantics, and they both take parameters, return a result, and then that result can be any level of depth. But you're supposed to be modifying with mutations versus only querying with a query. And I suppose you could do things like cache your queries and not cache your mutations. So by having them in separate named things, you can control how that happens. How widespread is GraphQL usage in enterprise implementations? I don't have a deep understanding of that beyond the fact that there are a lot of companies that say they're doing it, but we've run into a number of clients at Chariot who have said to us, we're using React or we're using Angular, and our API we're using is GraphQL. So, and that was even over a year and a half ago. They were using Apollo, one of the clients, and very successful application. So it's out there in some communities. I don't know the depth of it in the Philadelphia area, for example. It'd be good to know. You guys are using it? Yeah. Yeah, so it's out there. I'm assuming it's big. I have not been as deep in it as I would like to be. How do we know the request is post, put, or get? Good question. I actually did that in the query tool. I had the dev tools open. Since these are Electron apps, you can toggle on or off the dev tools. And we send request. And of course it failed this because it's broken, but insert bug here. But if we look at the headers, it's a post. Okay, so they do issue posts. There is a way you can switch it from post to something else. I know I read that, but they're basically saying you can, but why would you? Because a post, you send the output, and it's not on the query string, so it's not easy to steal what you're doing. Especially if you're using SSL, posting with SSL is pretty secure. So we shop with SSL and posts, right? We don't shop and send things on a URL and a get. So that's why they do post. And they don't do put or delete. It's the mutation is the same thing. It's just a post to an endpoint. Same endpoint, GraphQL. verbose error information to the client. They actually do. I'm actually getting stack trace information sent to me when something fails. It's a little painful. But I actually will get the stack trace of where or at least part of it. Seems like they cut it off on the Java side after a few lines. But it will give me enough information I could go to my server and look at the stack trace and see what's going on. So in the payload, there's the data, and then there's also like GraphQL error, and there are network errors, and there are different types of error payloads that you can look at. And they're defined in the standard. Any limit on depth on graph hierarchy? Probably just rational limit more than anything else. I haven't heard of anything. Probably not. Oh, there's one down here that I want to jump into real quick before you guys get sick of me and walk out. Has it happened yet? It's starting to happen. Good. I'm teasing you guys. So how do you model one-to-many or many-to-many relationships? This is one that's interesting to me. If you've got a multi-layer, multiple, parent-to-child, child-to-child relationship, and I've just been burned by this. Let's say I had a quiz that has questions and the questions have options. So I think I'm going to set up my schema as quiz with question with options. Guess what? You try to query all the way down to there, and you have no question, you get an error. That was disheartening to me, because I would think that it would just cut off the graph where it doesn't, depth-wise doesn't traverse, but it doesn't seem to. So that's an area for me for research to see what to do. But what I did is I flattened everything out into 3 different parallel trees, because they kind of work that way, current question, current options. But if I'm going to give them a depth of things, they all need to be not null. That's kind of irritating. And when I search for it, it seems like it's a common problem. So that's something to research to see if that's going to stop you from doing what you're trying to do. I don't know OData. There's the answer to that one. So it's different. How's that? You're welcome. In REST, you scope your operation to a resource. Is it standard to group GraphQL queries to a certain URL or really put them all in one endpoint? So if you're going to truly have separate subsystems, you could have different GraphQL endpoints serving the schemas for those subsystems. That would be what I would guess you would do, because you really don't have anything beyond the endpoint that you can put out there. So that's what I would probably think at first, is do it like service boundaries. So if I've got some sort of system boundary that makes sense, maybe there's a GraphQL endpoint for that boundary. And then for another set of things, there's a GraphQL endpoint for that. Unless someone says, but I need to query across all those, then you just kind of go, you don't really anyway. It's not like you're joining data together, right? You don't have like a SQL query ability. It's just methods that return graphs of data. So it's even less important if you split them up. And then the last one here, I think, how do you prevent unauthorized queries to your database when the GQL is right in the browser? Are you saying that you're not authenticated? Is that the question? So if you're not authenticated, how do you prevent it? I don't know who the questioner was, but if I understand the correct question, it's around authentication, I think. And so that would be the JOT token, for example, as one way of doing it. So you can secure the endpoint by, when they go back through again, if they've got a token, taking a look at the token and validating the token is valid. If the token is valid, they can continue, and whatever the rules that token is assigned based on your security system, you should be able to get to. And if you aren't assigned the right role to access something, you should get an access denied. And that's really, it's going to be very system dependent based on the security system you have on how you wire that up. So for me, it was Spring Security. And since Spring Security supports token-based authentication, it was I wouldn't call it a snap because it was Spring Security, a little verbose, but it was pretty straightforward. It took me less than a day to get all that wired up and tested. So it wasn't the worst thing in the world. Whereas I spent days with GraphQL on Express with Apollo, trying to understand the documentation to properly set up security for everything, because the docs weren't so good. So your mileage will vary based on the vendor you pick for your GraphQL API too. So if you're going to look at it, make sure you pick a language you're comfortable with, and make sure you pick an API that's well documented. Especially around the subscriptions, that stuff isn't all very documented. How is transactions handled? I'll grab that too. In my case, I use Spring for the transaction support. So once authenticated, once the call comes in, I secured my services with, and then I did @transactional on the service, and whatever it did was all transactional. And if it was a query, I used the read-only, so I would not do any heavy-duty locking. And then the rest of them, it's going to depend on what you integrate with it. But there's no such thing as like a two-phase commit. I mean, that's in general with web services, right? Hopefully everyone realizes here that if you're going to do like an SPA application, single-page app, that when you hit the server, there's no such thing as a transaction across 4 of those things, right? Usually what you do is you bulk up everything you need to do, make one API call with all of the payload, and it either works or doesn't, and it then turns into multiple calls, right? So that's, and on that side, then the server is doing the transaction. So that's the thing to think about. Batch up what you need to do, send it as one payload, and it either all works or it all doesn't. So hopefully that's been useful. Any questions? You know, you throw things up on the hashtag PhillyUTE. I'm @RimpleOnTech, and I'll tweet to the hashtag with our slides tonight sometime. So you can grab those from me that way, and they'll eventually be up on the website as well. But thank you very much.